So I would like to share with you some of my experiences with the ChemCurator. So when I think ChemAxon, I think chemistry, and I assume that majority of people in this room are chemists. But let's check it out. So if you're a chemist or you have been a chemist at some point in your life, can you please raise your hand? Okay, so I was right. So I think all of us share a common language, and I don't mean English when I say that. So let me demonstrate to you what I mean. H2SO4, it's inorganic compound. It's a very strong acid when it's dissolved in water. Chlorine, it's a small non-polar molecule. It's a gas, and it's a chemically reactive one. So Janos, watch for your double bond band. It's in danger. Then nitrogen, it's another small non-polar molecule. It's also a gas, but with its triple bond, it's not chemically very reactive. Iron, it's a solid, it's a metal, it's a conductor of electricity and heat. This is another solid. It's alumosilicate, but this one is not conductor. So what is this one? Yes, it's explosive, right? What is this one?
That's sugar.
Yes, it's sugar. And plants stock it as a fuel. And whoever worked with carbohydrate chemistry, you know how sticky they are and how you cannot get rid of water in your solution, so they allow water. So this molecule, it's a bit opposite. It doesn't like water, it's volatile. It smells like banana. This one is also volatile. It's called lemonen, but it smells like orange. What is this one?
Caffeine.
Yes. What is this one? It's cyclic AMP. So it's very important signaling molecule. So what I wanted to show here that all these squiggles, to those who are initiated, they mean something. So non-chemists will recognize them, they are chemical structures, but they wouldn't necessarily know how to interpret them. In the way how I can recognize when the word is in Arabic, but I don't know what it means. So for those who understand language of chemistry, these structures give a lot of information. So from this chemical structure, we can deduce what are molecular properties. They can tell us about bulk properties. Presence of certain functional groups will tell us about chemical reactivity. In some cases, we can deduce about biological activities. And while this is true for all chemical formulas, I think in this room we kind of tend to focus on organic compounds. So why would we need this chemical data for? So I'm borrowing a little sign from NIME, which I think it's a very nice and simple way to show what we do with basically most of data. So we want to access this data, want to eventually to transform it, want to analyze it, and then use these results. So for example, if you have a list of molecules, some of them are biologically active, some of them are inactive, and you analyze it, you say, oh, I need the heterocyclic nitrogen position 3 to have a biological activity. So this is a useful analysis, so it tells you a little bit about your next step. So this is why I need this chemical data. So where does the chemical data typically come from? So on one side, we have documents in a chemical structure format, like SDF, Marvin, databases with chemistry cartridge, and then all the other documents that don't have it, and they're typically more numerous documents, so publications, patents, catalogs, and a lot of internal documents that we created. However, if we want to use chemical information in an automated way, then we have to convert them into the format that understands chemical structures. So typically in these general documents, we will have chemical information as images of microstructures, as different names or different identifiers. So before we can do something in a kind of advanced way with these structures, and if you want to do it on a larger number of chemical data, then we have to convert it into computer readable format. Therefore, so we have to start with these general documents, and we have to get it into chemical structure documents. And now when we have it, there are so many different methods that we can apply to this set. So we can calculate fingerprints, properties, look for similarities, get conformers, we can do molecular docking, virtual screening, etc. And a lot has been invested to make all of these methods really fast. And yesterday we heard from Gabor and from Wolfi how you can do some searches in milliseconds. So this part is really very fast. But then what often tends to be a bottleneck, it's really getting from here to there. It looks like a trivial step, but it's actually the one which is time consuming. So in the old days, what would you do? Well, you pick your favorite music, you get a cup of coffee, and you start drawing structures. And then you're glad when you have a nice drawing program like Marvin, where you have some kind of spreadsheets that you can keep adding your chemical structures, and you're really grateful that there is copy-paste function. However, then ChemAxon came with a nice new product, ChemCurator, which is there to kind of help you with this first step. And thank you, Arpad, for the introduction, so I don't need to go in details about this one. And as RP said, so you will read documents in different formats. ChemCurator will recognize and annotate chemical terms, like in this case, recognizes aspirin and connects it with a chemical structure. We'll also do it for the images. And all these recognized structures then can be exported into a chemical structure file. So normally no duplicates are allowed. So here you will see that acetyl salicylic acid is also recognized, but it's not exported as a second molecule because it would be the same as the first one. And what you cannot see so well on this image anymore, but this structure here was not recognized in a completely correct way, and therefore it's very good that one can actually do the manual correction. And of course, the program will not recognize pictures. It only recognizes the formulas. So let me give you a few examples of how I use ChemCurator in my daily work. So I wanted to see which amino acids can be bought at Sigma Aldrich. So of course, you could type the amino acid substructure and do the search on their website and probably get some document in very useless format. But however, they have one of the catalog called amino acids, which gives you names and some information, but doesn't give you structure. So we want to kind of go there to the list of structures. And this is what one could easily create with the ChemCurator. So it's not a completely smooth sailing. In some cases it is. You kind of click a number of buttons and you get your final results 100% there. In many cases, you have to take a little bit closer look and ensure that data are of quality that you require. So when we look here at the first case, it's O-acetyl L-serine hydrochloride. So this is the molecule shown here and was exported as such, and it's correct. No comments. If we look at the second one, okay, you may ask yourself a question, why would Sigma Aldrich chemists put a nucleotide on the amino acid catalog? But that's a different topic. So you could see that the processor did not recognize full word, and probably because there is a missing dash here. So only recognize this as one part and made you this adenosine 3-phosphate. So this required human intervention to get this phosphosulfate substitute in the position 5, which is the one that was exported as well. So often when you look at these discrepancies, how the chemical terms in text were translated, there were either some kind of typos, like missing dashes or extra commas. In some cases, there are certain modulators. We will have like a butyric acid, methyl ester. which is not necessarily recognized as methyl butyrate. Or if it's kind of a catalog, you will have some additional information like reagent grade and purity. In some cases, that can kind of confuse the algorithm. And also, there are different ways how you can specify stereochemistry. Some ways are sometimes recognized, some ways are not. In the second example, I want to show you one work with a patent. Normally, when I work with patent structures, I would rarely annotate complete patent document because they are often kind of 100 pages long with a dense text. But I would scroll through it and identify pages that are of interest to me. So in this case, I've selected 5 pages with structures which I annotated, and I did an automatic extraction. So when I did this, out of 20 structures, 17 were extracted automatically. But when I took a closer look, actually only 1 was correct. So we need to intervene here. So when I looked what the reasons are, I could see that whenever there was a nitrogen in the structure, there were some problems by Clyde, because I'm using Clyde for image recognition, the way this nitrogen was recognized. So you could see that in this structure here, so this nitrogen is still present, but it's kind of floating lonely in the air. And it's the same thing with the second nitrogen here. So clearly there is some problem, either that the image quality is not good enough, or maybe depends on the font which was used in the image. Still in the same document, okay, we have again the same problem. The same nitrogen is creating problem, and here chlorine is kind of also misrecognized. But nevertheless, we still have good part of the structures there, and it wouldn't take a long time to basically put it in the right format. And the second structure, this one is almost correct, but actually this was one of the 3 structures that were not automatically exported. And the reason for that, I believe, is that not all atoms were recognized. So in these 3 molecules, there was sulfur atom that was either translated into question mark or a star. And at least the version of ChemCurator that I had did not accept these molecules. So maybe it would be interesting to export this molecule nevertheless, but then add a warning sign to the user that needs to be checked. And maybe Arpad will tell me if this is already in there or could be added. There are some really, really difficult cases. This is another patent, and you could see that the image recognizing program really had troubles with this one. But nevertheless, even in this case, so here I focused on some 20, 30 structures in this patent. It really didn't take me much time to generate my proper table. So starting with, say, the first structure, you could see it was like complete gibberish, the way Clyde did it. But then you would just basically delete everything which was there. You would type AMP, do name to structure. You have your AMP core. You add cyclopropyl, and you already have your structure. And then, again, especially if you are annotating a patent where most of the structures are related to each other, again, you can really benefit from copy-paste function. So even if the curating a document requires manual intervention, I still see a big benefit in using it rather than doing it completely manually. And one of the reasons is that it provides kind of this platform for linking chemical entities in a document with a chemical structure. If I had to do it manually, there is definitely more room to make errors, and I would definitely skip some. And again, benefiting from this copy-paste, so I can easily then copy the first structure, and then when I click on my next entity, I can just paste the structure, do the necessary modifications, and have it ready. So typically, in this case, it would take less than 30 seconds to make the structure. I also, at the moment, I was thinking that in some cases where no entity was recognized, it would be nice to be able to create one, but Arpad explained me that actually this is already in there. This is already possible. As the last example, I just want to show enumerating one MedChem paper, which is like probably one, aside from patents, another highly popular document source for this kind of applications. So here I did this automated extraction, just excluding small molecules. So you can see glucose is well done, phenylpropionic acid is well done. Dihydrobenzofurane, the next word is derivative, we got, it is some dihydrobenzofurane derivative, but it wasn't clear to me like why these decorations under this dihydrobenzofurane. So I would kind of prefer just to have the core molecule without these decorations. And in this line here, this is kind of the key molecule in this paper. So there were problems in recognizing the full name, maybe because it's chopped in 2 lines. And it's not really, this is part of the abstract, so it's like just on a part of the page. And another thing that I noticed, although the kind of this part of the structure is correct, it added this oxy, but it kind of added it arbitrarily here. So this is not clear to me where this kind of selection of the substitution point came in. But in this paper, because it also involves the procedure, I also got a glutathione export, and I got all the amino acids that were present in the buffer that I don't necessarily need. So in this case, it was very useful, aside from having this molecular weight filtering, to add also the substructure filter. And very simple filtering just on benzene would basically reduce the number of structures that are exported, so we can see some more molecules. Again, the first 2, we are happy with them. Here there is another case of this kind of arbitrary substitution point. This is benzyl oxy, but normally actually in the paper they are targeting the position 4, and that's not the position here. And in the last one, there's also benzofurane derivative. Again, we see benzofurane, but then it's not really clear where kind of what is the source of this other application. So these are maybe a couple of cases for you that you could look at and see where this originate. And what was a little bit surprising to me, that in this publication there were only small number of images of chemical structures, but the ChemCurator did not recognize them. So my first thought was, could it be because there are errors here, or this is actually kind of a Marcouche structure, and I don't have the kind of license for handling Marcouche structures only for compounds. But then upon kind of with further investigation, I tend to believe that it's actually due to Clyde, and lately we have had some problem with Clyde functioning. So I've shown you several cases. I've shown you some kind of more difficult ones, because those where it kind of went smoothly, I thought it's not so interesting to present them, but there are still many of them. And what I can conclude first, having access to chemical data in the right format is really critical. It's very often the slowest step in your working process. And then tools such as ChemCurator are really needed, because they really help us with this first step. At the moment, full automation is still not accurate enough to use these programs in an unsupervised way. But even if this automation requires some manual intervention, it is still a great added value, and it really first helps us the way we structure documents, and also saves us a lot of time. I would say even with these corrections, it saves you 3 to 4 times the time you would need it if you had to do all the work manually. And with this, I would like to thank you all.
Because you mentioned a presentation a few hours ago, so I had a quick look at your slides, and so I could give some start of comments on these cases where it was not perfect. So it's quite interesting. There's this case with the benzofurane derivative, where you see a specific molecule when you would expect, well, it could be any derivative, we don't know. So as I kind of suspected, what happens is that in our dictionary, we have, of course, about 150,000 names, so we don't do them one by one, we use sources, and some of them make mistake. And what I could do is actually look at all these cases where, so the dictionary source that we use has a name and derivative at the end, and they actually give a specific structure. And so we could obviously filter this out to avoid this issue. I checked that, so there are about a bit more than 100 cases like this. So it will be an improvement, I think, in a couple of weeks. It could be there in the next version when you upgrade. And the other case where actually the key compound was not fully recognized, just part of it, what I just had time to see that the name itself is understood, and even with the line breaks, it still works. So I suspect it's something to do with the PDF, and in this case it's converted to, PDF is already a display format, and then it's converted to HTML. And somewhere in this process, I think something is missed from the presentation. So we can see if that can be fixed. But the other interesting thing is that because this is an article, I saw that it's on PubMed, there might be actually a way to get the text in a maybe more structured format, so not a PDF, and then maybe that would be an integration that could be done to improve the conversion. We'll look into that.
Thank you.